Hi, everyone. My name is Sean Winn. I'm a senior solutions architect at APIServer. Today, I'm going to talk about a new feature in Cilium 111 that allows you to write Cilium network policies, matching your Kubernetes API server very easily. First, I'm going to take a moment to discuss the problem statement and help you understand why we want to solve this problem in the first place. Then I'll give you a brief introduction to Cilium network policy entities and show you where you can find some more information about them. And then after that, I'll demonstrate what a policy example using this new entity would look like. And then we'll go into a live demo where I will show you this working in a live environment that I have running in a cloud provider. So why do we care about this? Well, first off, the Kubernetes API server address is not always well known to your users. It's not always known what IP address or even what URL might be used for the API server. And while it might be easy to find in some cases, it's not always easy to know how to populate your network policies. So it makes it very difficult to write policies that might relate back to the API server, especially for users of the platform who may not be privy to all this information. Making this even more complex, it's totally possible that the IP address of the API server changes in some cases. And I will show you an example of that taking place in a cloud provider where the IP address of the API server just changes every 15 seconds. And then beyond that, there are a number of products that run within Kubernetes that use webhooks that call back to the API server. And these webhooks frequently require unfettered access to the API server in order to be able to do their jobs. So we provide a way within Cilium network policies for you to use a simple construct called an entity. And with entities, we can provide a simple way for users to write policies that allow access to a generalized set of services. And one example that's new to Cilium 111 is the kube-apiserver entity. And you can see here that this represents entities and deployments that are both inside the cluster and outside the cluster. So it allows the user to write a policy using this entity, and they don't need to know what's the URL of the API server, what's the IP address that I need to allow in my network policies. So if you were to actually write a very simple policy, in this case, this is what it would look like. And in this policy, I am selecting all endpoints because my endpoint selector is an empty set. And then I'm specifying that these endpoints can egress to the kube-apiserver entity. And this policy will allow anything that selects it to be able to access the API server in a Kubernetes cluster where you have tightly controlled access using any form of network policies. So let's go ahead and switch over to a live demo where I can demonstrate this in a live environment. On the left side over here, I'm watching all of the pods running inside of the kube system namespace. And this is just refreshing every couple of seconds. And so I've got a cluster that's deployed here in Amazon EKS. And so this is a good example of where the URL for the API server is some randomly generated URL that Amazon has provided back. And it may not always be clear to the user how they would provide access using a network policy to something that uses this type of a location or address. If we were to make this even more complex, if I ping that for a small amount of time, and we allow this to, did I not, I missed something. Sorry about that. What we notice is that the actual IP address backing this is going to change. So over some period of time, takes about 15 seconds or longer, the IP address backing this URL is not changing. Okay, so it's not changing. That's okay. It did change yesterday. So, but if the URL did, if the IP address backing this changed, as it commonly does with anything backed by a cloud provider, the user would not know very clearly how they would be able to write a policy that would encompass these those identities. So what I'm going to do right now is I'm going to apply this policy. And what this policy will do is it will take the cert manager deployment that's running. Okay, so I'm going to put my cert manager deployment into a default deny state. So what's going to happen is then the cert manager will no longer be able to reach the API server. And by doing that, cert manager will not be able to actually do its job. And I'm also going to add this policy in just so that you know that I'm adding it. And what this policy does is it allows inspection of DNS similar to what was demonstrated earlier for the FQDN-HA. So I'm going to apply both of those policies into the cluster. And what this is going to do is it's going to put cert manager in a state where it's no longer able to work. And we'll actually see that based on the CA injector and the cert manager service should go into this state where they start to crash and they're no longer able to communicate with the API server. The other thing I'm going to do is I'm going to create some objects here. And these objects are actually certificates and secrets that are used by cert manager. So if I were to take a look at what I'm actually creating in one case here, I'm creating an issuer. And that issuer is just a Cilium CA issuer. But what we should note here is that it's supposed to create a secret for me. And that secret is got a name, Cilium CA cert. So if I look in my cluster and I try to see if that certificate exists, I can see looking for the secret that it's not there. And I could see that cert manager has actually restarted one more time and has gone back to a running state. So if I describe this pod and take a look at what's going on with this CA injector, I can see that it had an error and it terminated. So if I wanted to know why did this actually terminate on me, if I take a look at the log file and look at the previous log, I could see that it had a problem. It couldn't connect to the API server. So the policy that I put in place to lock down cert manager is actually doing its job. And that's kind of what we expect for it to happen. So I'm going to take this policy now, and this policy is going to allow anything inside the cert manager namespace to be able to access the kube-apiserver. So if I take this policy, I'll go ahead and apply it. So now I've got a policy in there, and now it's allowing access to the kube-apiserver. So now I'll see the CA injector just came back online. And so if I give it just a couple of seconds to actually do its job, what we'll see is in a minute here, I should see that there's a secret created for the Cilium CA cert. Let's see. Okay, so I see now my Cilium CA cert is ready. The secret is there. I see that the other, the issuer is now online. And if I go back and run kubectl get secret, there's my certificate. All the services are back online. So applying that policy allowed everything to just start working again. And that's the basics of it, a simple policy to allow access to the Kube API server.